Good morning to everyone. Myself, Dr. Chinna Dastagiri Goud, Assistant Professor, EEE Department. So today I am going to give brief introduction about the principle of electrical and electronics engineering. So this subject is common to CSE, CSE allied branches, that is AIML, AIDS and CSE data science, and EEE, ECE and biomedical engineering. So coming to the chapters, it is consisting of 5 chapters. So the unit 1 is introduction to electrical circuits. So here what are the topics we are going to cover is what is the circuit concept, so what is the loop, what is the circuit, what is the node and extra, and the electrical circuit elements, the basic elements of the electrical, that is resistor, inductor and capacitor. So then we will see the types of sources. So we have the current sources and voltage sources, and transformation of current sources into voltage sources into current sources for analyzing the circuits. Then we'll go to the voltage and current relationships in these passive elements, this resistor and inductor and capacitor. So these passive elements, what is the voltage and current relationships, and then we'll go to the Kirchhoff laws. So we know the basic laws, Ohm's law. So Kirchhoff laws we will see. So in the circuit, how these laws will be useful. Then we will see the network reduction techniques. So to solve the networks, how to reduce the networks. So for example, series networks, and we are going to check series networks, parallel networks, series parallel networks, and the networks which are not series parallel and series parallel, they will be generally star to delta form. So how to convert that star form to delta form and delta form to star form, that star to delta transformation techniques. Then without reducing the network, how we will analyze the circuit. So the Kirchhoff laws we studied, so that Kirchhoff laws applications we are going to see, that is mesh analysis, which is the Kirchhoff voltage law application, and the nodal analysis, which is the Kirchhoff current law application, and the numerical problems on these things. So including this, we are going to see some special cases of mesh analysis and nodal analysis, that is super node and super mesh analysis. So all these problems we will see for the DC excitation. As our subject is the principle of electrical and electronics engineering, we are going to deal with only DC excitation problems. So coming to the second chapter, this is single phase AC circuit. What we seen in the first chapter is the DC circuits. We'll come to the second chapter, we'll deal with the single phase AC circuits. In this one, first section we'll see with the what are the waveform, different periodic waveforms, because our AC circuits also is a periodic waveform. First we have to understand what is the periodic waveform. So we'll see the different periodic waveforms and what is its characteristics. Like we will calculate the values of RMS values, average values, and the form factor and the peak factor of the different periodic waveforms, including with the sinusoidal waveforms. And then we will see what is the steady state analysis of the passive elements we see in the first chapter, resistor, inductor and capacitor, with this single phase AC input, and the combination of these things like RL series combination, RC series combination, RLC series combination and parallel combinations. These two combinations we will see, series combinations how it will act and parallel combinations how it will act. So when these circuits we are analyzing, there will see some concepts. So in that circuits, so we'll understand the concepts of these AC circuits also. Those things will involve with reactance. What is the reactance of the circuit? What is the impedance of the circuit? What is the susceptance of the circuit? And then what is the admittance of the circuit? What is the phase of the circuit? Phase difference, power factor, real power, reactive power, complex power, and how we will make this real power and complex power things in a forms like complex form and polar forms. So these are the basic things we will discuss in the second chapter, and we'll do some numerical problems on these circuits and by using these concepts. So coming to the third chapter, so this is basically about the theorems and also the machines. So some theorems, network theorems, up to now we've seen how to analyze the circuit and everything. So in this chapter we are going to see some network theorems. So the theorems involve Thevenin's theorem and Norton's theorem. So these two theorems mainly we will see in the syllabus, and the superposition theorem also one more theorem which we will discuss. So these three theorems we are going to discuss in this chapter, and some numerical problems on these theorems with the DC excitation. So same theorems we also will do in the practically in our lab sessions also. And coming to next, we have the machines. So two types of machines, we have DC machines as well as the AC machines. So we'll see the basic principles of these machines. So in coming to the DC machines, we'll see the types of machines and what are the construction details, and along with that one principle and operation of the DC generator and DC motor. Okay, then we'll see the EMF equation, So induced EMF in the DC generator, derivation of the equation and some numerical problems on that equation, and we will see the applications of that DC machines, DC generators and DC motors. And coming to the AC machines, again we have static AC machines and rotating AC machines. So in static AC machines, we will see the transformer. So basically we will understand the construction and principle of operation of transformers and three-phase induction motors, alternators and its applications. So this is the third chapter, and up to here we will go with the electrical concepts. And the fourth chapter, fifth chapter, we are going to deal with the electronics topics. So fourth chapter is the PN junction diode and rectifiers. So the basic concepts of PN junction diode. So what is in PN junction diode? We will do the review. So we'll do the review of PN junction diode, how it is forming, what is the P type of semiconductor, N type of semiconductor, the basic things, and we'll see the VI characteristics of the diode, how it will act. Then coming to the rectifiers, we have the topic how diode is acting as a rectifier and a half wave rectifier, full wave rectifier with center tap transformer, and the bridge rectifier with filters like capacitor filter and inductor filter, how it is acting. Then we'll see some special purpose diodes also in this one. So the devices, the diodes which are specially designed for some particular things. In that one, Chinna diode, which is used as a regulator, SCR as a rectifier, silicon controlled rectifier, tunnel diode and varactor diode. So these are the four special devices we are going to discuss in this chapter. So coming to the fifth chapter, it is the bipolar junction transistor, simply called as BJT. So we will see in this one what is the construction and symbol of the BJT, principle of operation, and what are the current components involved in the BJT, and the configurations, working configuration of the BJT. So the main thing, common base configuration, common emitter, common collector configurations we'll deal with, and then we'll see what is the AC load line and what is the DC load line in these BJT configurations. Then we'll talk about the concept stability and what is the stability factor, then thermal runaway. So these are the topics we will discuss in the fifth chapter, bipolar junction transistor, and we'll go with the numerical problems with elementary operation on stability and everything. So this is our PEEE subject brief discussion and what we are going to deal with in this semester. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.